In today's Tech Corner, I'm here with Rodney from Langley Alloys, and we're going to take a bit of a dive into Alloy 718. But what is Alloy 718? Well, Rodney, this is where you come in with your expertise. So give us a bit of an insight into 718.
No pressure at all. Right, so it's a nickel alloy. What does that mean? It means that its main constituent or component is nickel. The primary reason for basing alloys around nickel is that they operate over a wide temperature range. So 718, Inconel 718, it can be used from like minus 250 degrees centigrade up to 500-600 degrees centigrade, even higher, but it will retain its strength and its properties over that really wide range. It will go higher still and the strength will start to drop off, but one of the primary reasons is that wide temperature operating range. So it's not much of a surprise to know that its initial main applications were in the aerospace industry. So think of gas turbines that are operating at high temperature. Now, these days it will be used in chemical processing and oil and gas, where you have that really good combination of high strength and high strength at high temperatures with decent corrosion performance as well.
Now, this material has been around for quite a long time, and obviously it will have started at quite a specific application. But like you've just said, it's now widened its horizon to be used in quite a lot of industries. So how long has it been around?
Oh, you must be talking about 50 years plus in terms of being in the marketplace, and that fact that it's been so widely used is one of its strengths, in that from a customer's perspective it's relatively widely available. You know, there are quite a few different manufacturers and it's stocked in quite a few different places, so the fact that it can be found reassures, I guess, the supply chain that it's a sensible choice. You know, they're not going to be left high and dry.
Now, I want to talk a little bit about the temperature strength, because obviously, like you've said, it can be used for quite a range. So what sort of applications is that good for?
Well, if you're talking aerospace, you know, the obvious application is around the turbine engine, which is running hot. But if we move into oil and gas, which is a little bit more of a modern, more contemporary application, the conditions at the bottom of an oil or gas well aren't, you know, room temperature or sea temperature, seawater. It's 200, 250, 300 degrees plus centigrade, combined with all sorts of challenging, nasty chemicals or fluids that are surrounded by it. So you're wanting something that's going to keep its strength and its toughness and its corrosion resistance at 200, 300, 400 degrees centigrade. And that's the whole reason for moving to a nickel alloy such as 718.
And obviously, to get parts in 718, we've got to be able to machine it. So what is it like to machine?
Fortunately, I'm not a machinist, I'm a materials guy, so I could easily say not my problem. But nickel alloys are notoriously challenging to machine. Nickel has got, relative to steel and iron, very low thermal conductivity, so there's a tendency during machining to build up temperature at the tip and get excessive tool wear. The thing's bloody high strength as well anyway, so you multiply that thermal build-up and challenges around tooling selection with the fact that it's just high strength as well, and it will work harden. So if you're taking a little bit off and going slowly, the thing's just going to get harder and harder as you go along. So there's quite a few threats or challenges really when it comes to machining. That said, it's been in the marketplace one way or another for 40, 50 years, so people have figured out the right tooling and the right conditions. Just don't ask me exactly how to do it, but I could refer you to a customer who'll tell you exactly how to do it.
Yeah, but I like how you've just said, I'm not a machinist, but then you've gone down and started talking about tip wear and work hardening, which is the two main problems any machinist will face machining this. So I think we should give you some credit here that you know all the lingo and you know what problems come with it for somebody to actually have to face.
I think that's a little knowledge is dangerous, perhaps. Tom, moving on.
Now, obviously, we've talked about machining it, but before you machine it, we've got to buy it.
Yeah.
So what is the cost of this sort of, what is the cost around it?
So, the cost will go up and down. So, although nickel as an alloying component gives really cool properties, it's also an expensive metal, and it's also quite volatile as well. So, at the moment, depending on the size and the specification, you're 30, 40, 50 pounds a kilo at least for this metal. So it's not cheap. You then have to think about the specifications. So its main applications are aerospace, so it tends to come with an AMS type specification, or for oil and gas it's API. So already you've not just got 718, is it API or AMS? Which strength level is it? 120k, 140k, 150k? It comes in different conditions as well. But coming back to it, why is it so picking expensive? It's high nickel content, which is expensive. During its manufacture, it has to go through vacuum remelting. To achieve the high strength, you need a very clean internal structure. And then it has additional heat treatments as well to achieve those elevated strengths through a precipitation mechanism. So it uses expensive materials and expensive processing to give you a high performance product with lots of testing and certification around it.
Can you just clarify the remelting process of that?
Oh.
Because that was the bit I didn't really get, because I've only got one more question after this, I promise.
You'll start with a pile of scrap and alloying additions, which you will melt. You'll typically melt it under a vacuum to remove gas, oxygen or nitrogen. But then after it's solidified, you'll then remelt it again under a vacuum. And that very slow remelting process helps to remove, undesirable contaminants or elements within the metal. So in the steel industry, you'll talk about steel cleanliness, which is freedom from these little undesirable particles, because those particles can screw up the properties if you're not careful.
So essentially, it's a clean alloy then. You've not got all the little bits of dirt from around the factory inside it. Now, just before we finish, we've quizzed you a little bit on how to machine it.
Okay.
But I've got one more.
Go on.
How is it to weld?
Oh, now I think I was stepping outside of my my knowledge base on machining. For welding, I'm a long way out there, but there will be a set of conditions. But the main requirement, I would assume, is that you're using the right consumables, the right filler metals. So the materials you're using together with it will match the composition of the two items either side. But I should really plead the fifth on welding.
Well, I wouldn't like to try and talk too much about welding, because obviously you've already said it can work under quite high temperatures. So obviously if you're trying to weld it and you're trying to heat it up, trying to heat it up enough to then weld it must be another problem in itself. But we'll leave it there for now. So if there's anybody at home who doesn't know about 718 and would like more information, how can they get in contact with you guys at Langley Alloys?
It's easy enough. We operate a big warehouse in the UK, a big warehouse in the US, so there'll be somebody from Langley Alloys sitting at a desk probably 16, 18, 20 hours a day. So we've got most of the working day covered, and the easiest way is just to find our website and take it from there.
Well, Rodney, from me and everyone at MTD, thank you for your time, and thank you for being in the MTD Tech Corner today.
You're welcome.